Jai Hind students, today we are going to start the 9th chapter, Algebraic Expressions and Identities.
Algebra. It's simple. It's all about puzzles. Here's one for you. This plus 2 equals 5. We just have to find the number in this box. Which number, when added to 2, gives us 5? Simple. It's 3. We can say that 3 plus 2 equals 5. This thing we see here contains only numbers. This puzzle can also be asked in a different way. We can say that x plus 2 equals 5. Find x. We just used a letter in place of the box. These letters are also called as variables. Sometimes also referred to as the unknown since its values is not known to us. This is algebra. It deals with variables and unknowns and we are expected to find their value. But why use variables? Why not boxes like these? Let's assume there are 3 unknown numbers. Using shapes, we can write it as a square plus a slant square plus an empty circle plus 4 equals 7. You had to think of different shapes. Using variables, we can write it as x plus y plus z plus 4 equals 7. This was a little more convenient as compared to the previous case. But what's the real advantage of using variables? Read this short story and the question that follows. Your friend had a few chocolates with him. A bully came across, took away 5 of his chocolates, and then he had just 7 chocolates remaining with him. How many chocolates did he have before the bully came to him? This question has 40 words. Let's see if it can shorten the question a bit. Assume your friend had X chocolates with him. The bully took away 5 of his chocolates. So we subtract 5 from X. And after all this, your friend was left with 7 chocolates. This entire thing will then equal 7. Now all we have to do is find x. This entire question of 40 words can be written like this. So yes, algebra makes life simple. Write the sum of 3 and 7 in a mathematical way. The word sum means addition, and we can write this as 3 plus 7. This is an expression, and as it has only numbers in it, it's called a numerical expression. Only numbers, numerical expression. Now how do we write the sum of a number and 7 in a mathematical way? As we don't know what this number is, we can use a variable in its place. We can write it as x plus 7, where this x can take any numerical value. As this expression also has a variable in it, it's called an algebraic expression. Variables, then algebraic, just numbers, then numerical. Here's another statement we need to write in a mathematical way. The sum of a number and 7 equals 12. This can be written as x plus 7 is equal to 12. A number plus 7 equals 12. This is called an equation. It has an expression on each side of the equal to sign. Apart from expressions and equations, the most important concept in this topic is that of terms. Look at the number 4. It is just one term. What about 4 plus x? How many terms do we have in this expression? 2 terms, 4 and x. What about the expression 4 over x? This is just one term. One term when divided by another gives us only one term, not 2. Only plus and minus separate the terms. Multiplication and division do not. So here's the 4th example. 4 plus x minus y. As we have plus and minus, we can say that this expression has 3 terms. And what about 4x? As 4 and x are multiplied, this is just one term. So remember, plus and minus separate the terms. Multiplication and division do not. What are like and unlike terms? We will see that in the next session. To see the types of terms, we need to understand the concept of the power of variables. Let's consider two different terms. The first term is 7xy and the second one is 17x cubed y squared. Observe the first term. It has two variables, x and y. What is the power of each of these variables? The power of x is 1 and the power of y as well is 1. Now look at the powers of variables of the second term. The power of x is 3 and the power of y is 2. Both these terms have the same variables, x and y, but the powers of each of the variables are different. Let's erase this and jump to the concept of the types of terms. There are two kinds of terms, like terms and unlike terms. What is the difference between them? Two terms are like if they have the same variables with the same powers. Don't worry, we will understand this with examples. When are they unlike then? Two terms are unlike if they have different variables or same variables with different powers. Let's zoom out and understand a couple of examples. Consider two terms, say 7xy and 15xy. Are these two terms like or unlike? Remember, to know the type, we just have to look at the variables and not the constants. Both these terms have the same variables, x and y. But that is not enough to tell us if they are like or unlike. The next thing we need to compare is the power of each variable. The powers of x are the same in each term, it's 1. And yes, the powers of y in each term is also 1. As both these conditions are satisfied, we can say that they are like terms. Same variables and same powers of each variable. What about 3x squared y and 3xy cubed? Are they like or unlike? Both the terms have the same variables, x and y. Now let's compare the powers of each of the variables. Let's look at the power of x first. In the first term, it's 2 and in the second, it's 1. It's not the same. Even though the variables are the same, because the powers are not equal, these are unlike terms. Observe that we do not bother to check the powers of y in each case. Remember, if the powers of one of the variables is different, the terms become unlike. What about 8xyz and 8xy? The first term has three variables, x, y and z, and the second term has just x and y. It does not have z. Both the terms have different variables. Hence, they are unlike. Just remember these two things and you would have no problem understanding the types of terms.
Write the definitions in your notebook.
Expressions that contain variables and constants are called algebraic expressions. The letters such as x, y, l, m and so on are used to denote variables. So a variable can take various values and its value is not fixed. On the other hand, a value that does not change is a constant. So in an equation, 7x squared plus 5xy plus 8, x and y are the variables and 8 is a constant. Algebraic expressions are formed by combining variables and constants with the help of addition, subtraction, multiplication and division. Let us see how the algebraic expression 6x plus 9 is formed. It's really simple. First multiply variable x with constant 6, then add a constant 9 to the product. Similarly, 14y minus 30 is obtained by first multiplying y by 14 and then subtracting 30 from the product. So, children, you see these expressions were obtained by combining variables with constants. You can also obtain expressions by combining variables with themselves or with other variables. Now we will discuss what terms of an expression and their factors are. Consider the expression 9x plus 4. In forming this expression, we first formed 9x separately as a product of 9 and x and then added 4 to it. So, you have seen these expressions have parts which are formed separately and then added. We call these parts as terms. That means terms are added to form expressions. How many terms are there in 5x plus 3y? That's right, it has 2 terms. A term is a product of its factors. But what are these factors? Look at this term. We say that 3, x and y are the factors of the term 3xy. Do you know we can also represent 5xy plus 10 by a tree diagram? See, the dotted lines are used here for factors and continuous lines for terms. Remember, the factors cannot be further factorized. The numerical factor of a variable term is called its coefficient. See in the term 5xy, 5 is the coefficient of the whole term. Let us take this expression 12x square plus 4xy plus 4y square. It has 3 terms and 12, 4, 4 are the coefficients of the terms. When terms have the same algebraic factors, they are called like terms, and when terms have different algebraic factors, they are called unlike terms. Let us see an example. We have an expression 4xy minus 5x plus 3xy plus 2. Now, look at the terms 4xy and 3xy. The factors of 4xy are 4, x and y. Likewise, the factors of 3xy are 3, x and y. So both the terms have same algebraic factors, which means 4xy and 3xy are like terms. On the other hand, the terms 4xy and minus 5x have different algebraic factors. So, they are unlike terms. Children, see this algebraic expression. It has only one term. This type of algebraic expression is called mononomial. Now, is 5m plus 2 a mononomial? No, it has 2 terms. This type of algebraic expression is called binomial. The expression 6a plus 4b minus 2c is not a binomial because it has 3 terms, right? So this type of algebraic expression is called trinomial. Remember, all algebraic expressions that have one or more than one terms are called polynomials. Therefore, mononomials, binomials and trinomials are all polynomials. We can only add or subtract like terms. But why is it so? Think of it like this. On a table, we have 3 pencils and 2 books. We cannot add the 3 pencils to the 2 books because they are not the same kind of objects. Now, if we get another 3 pencils and 5 books, altogether, we now have 6 pencils and 7 books. Now again, we can't combine these objects since they are different. However, if we remove 1 pencil from 6 pencils, then we are left with 5 pencils, but still we have the 7 books. So you can't say it's quite similar with algebra. We can only add or subtract only similar objects. We have 2 algebraic expressions, 5x plus 4 and 3x plus 7. Let us find their sum. Identify like terms here, then add them. So, 5x and 3x are like terms, and so are 4 and 7. Further, adding 5x and 3x, the sum is 8x. Adding 4 and 7 is equal to 11. Therefore, the sum is 8x plus 11. Now, the question is to subtract 4ab plus 10b minus 16a from 30ab plus 12b plus 14a. We have to use the same criteria as we have used for the addition. Bring the like terms together, taking into consideration the sign of the terms. So on rearranging, we get 26ab plus 2b plus 30a. See this square? It has an area equal to L square. If the value of L is equal to 4 centimeters, then what would be the area of this square? That's right, it would be 16 centimeters square. So children, there are a number of situations in which we need to find the value of an expression. Consider the expression 4x minus 5. If the value of x is equal to 4, then the given algebraic expression is equal to 4 into 4 minus 5, which is equal to 16 minus 5, that is 11. Similarly, if m is equal to minus 2, then value of the expression m square minus 2 will be equal to 2.
Dear students, please copy all the definitions from today's video class and practice the example problems also.
Hello and welcome to Math for Juniors with me, Miss Marks, and my assistant Snail.
Oh, Miss Marks, I just lost some money over a bet. I still don't know how he beat me though.
Oh, what was the bet on?
It was about eating more chocolates.
And you lost it, huh? I can't believe this.
Actually, he kept laddus next to me. It was difficult to concentrate.
Smart guy, huh? You also should try and be smart, Snail, huh? People will come and use you otherwise.
That's true. The only way I can improve my smartness is by constantly adding knowledge.
Why just add, huh? Multiply your knowledge. Snail, you need to grow your intelligence faster.
Huh?
Oh, don't be so confused, Snail. Our topic under study today is related to multiplication. So, let's enter the virtual world and gain some knowledge on multiplication of polynomials. Look at this brick wall here. It's all around the garden. Guess how many bricks are used to make this wall? Well, the number of bricks in each side of wall can be obtained by multiplying the number of bricks in a row with the number of rows. But the number of bricks in the rows and number of rows may vary in each wall and hence involve variables. So in order to find the number of bricks, one needs to know how to multiply algebraic expressions, in particular polynomials. Sounds complicated, huh? Not to worry. Let's find all about it in this module on multiplication of polynomials, where we study how to multiply a monomial with another monomial and with another polynomial. Then see to multiply two binomials and then proceed to multiply a polynomial with another polynomial. Let's find out solution of the problem at hand. There are 9 rows in the wall and each row consists of y bricks. It means there are 9 into y bricks in the wall. Now, 9y is equal to 9 into y is equal to y added to itself 9 times. Now, let's consider if each row has 2 y bricks. then the number of bricks is 9 into 2y or 2y added to itself 9 times, that is 18y. In both the situations, a monomial is multiplied by another monomial and the product is also a monomial. Let's now consider some more examples to understand the product of monomials better. What about 4y into 2y square? Here, the coefficient 4 and 2 are multiplied first and then the algebraic part of first and second monomial, that is y and y square, is multiplied. So the product is 8y cube. Notice that the coefficient of product monomial is the coefficient of first monomial into second monomial. And the algebraic factor is also equal to the algebraic factor of 4y into algebraic factor of 2y square. What if there are more than two monomials? Then how do we find their product? To crack this query, let's take an example of three monomials: 5xy into 4x square y square into 7x cube y cube. First group 5xy and 4x square y square to get the product 20x cube y cube. This in turn is to be multiplied with third monomial 7x cube y cube to get the final product as 140x raised to power 6 y raised to power 6. This method can be extended to the product of any number of monomials. Now you know with fewer efforts how easy it is to multiply monomials.
But I like hard work.
All I can see is a hard-working tummy, huh? Nothing else. Well, let's move on now.
Yeah, let's move on to next level of multiplication of polynomials.
Alright, let's enter the virtual world. Now, getting back to our wall. Just wondering that if the number of bricks in each row of one of the walls is y plus 5 and the number of rows is, say, x, then can we still multiply the two expressions to get the number of bricks? The answer is yes. A monomial x and binomial y plus 5 whole can be multiplied using the distributive law. X into y plus 5 whole is equal to x into y plus 5 into x or xy plus 5x. So, once we know the values of x and y for a given wall, the total number of bricks that make the wall can be found out. Using this same method, a monomial can be multiplied with any polynomial. Let's check out the example. 3a multiplied by 4a plus 2b plus 3. Multiply 3a with each of the three terms 4a, 2b and 3. That gives 3a into 4a plus 3a into 2b plus 3a into 3. So, the final product is 12a square plus 6ab plus 9a, which is a polynomial.
Wow, that's so cool! All this sounds like some combo pack to me. You see, monomial being a single term expression is like chocolate. Binomial being a two-term expression is like a pav bhaji, and polynomial being a more than three-term expression is like MACD's combo offer.
Good one, Nair, good one. Now let's enter the virtual world and I'll show you how to multiply two binomials and polynomials, okay?
Haha, you too, Miss Marks.
Now let's go a step further and multiply a binomial with another binomial. Let's look at an easier method to do this. It's called the FOIL method. F stands for first, O is outer, I is inner, and L is last. Do the first term of each binomial first. That is 2a into 3a. Now take the outer terms, that are 2a into 3b. Next, multiply inner terms, that is 4b and 3a. Lastly, multiply the last terms, that is 4b and 3b. Now, which method is used to multiply polynomials with another polynomial containing more than 2 terms? Let's again see an example. Polynomial m plus 6 whole is multiplied with m square plus 3m plus 4 whole. Here, since first polynomial has 2 terms and the second polynomial has 3 terms, the trick is to multiply each term in the trinomial with each term in the binomial. That is m into m square plus 3m plus 4 whole plus 6 into m square plus 3m plus 4 whole. Now, m into m square is m cube and m into 3m is 3m square and m into 4 is 4m, right? Continuing with the second term a, we get m cube plus 3m square plus 4m plus 6m square plus 18m plus 24, which equals m cube plus 9m square plus 22m plus 24. Notice that the like terms have been combined.
I am a little confused. In multiplication of algebraic expressions, which type of expression is obtained when?
Just remember, Snail, multiplication of same type of algebraic expression gives an expression of that type. That is, multiplication of 2 monomials gives a monomial.
And multiplication of 2 binomials gives a binomial?
Yes, same is the case with polynomials. But when a binomial is multiplied with a monomial, then you get a binomial, and so on.
Cool! This is quick and easy.
And now it's time to explore world of polynomials in the Do You Know section for that. You know, Snail, the journey of finding roots or solution of polynomial is very interesting.
Well, what is the solution of a polynomial?
It's called zero or root of equation as well. It's the value of variable which makes the polynomial zero.
Oh God! How does one find this root?
Well, there are various methods to do so. One of them is plotting the graph of polynomial. You know, mathematicians Girolamo Cardano, Niccolo Fontana, Tartaglia, and Niels Henrik Abel are some of the notable mathematicians who worked towards finding the solutions.
Interesting!
Well, there's one more interesting story that the mathematicians Cardano and Tartaglia had a dispute as to who found the root of cubic polynomial first. Hey, it's time for a quick recap and then we are almost done. In this module, we learned that product of 2 monomials is always a monomial. FOIL, first, outer, inner, last method can be used to multiply binomials. Product of a monomial and a polynomial is a polynomial. Well, that's all we have today. See you guys later in another episode of Math for Juniors. Till then, take care. Goodbye.
By now you should have no problem multiplying out this expression. We have a monomial, or one term, being multiplied by a binomial, or 2 terms. To multiply this, we need to multiply each term inside the bracket by a. A times x equals ax. And a times y equals ay. Please pause to check my working. In grade 9, you also need to simplify the following type of expression. In other words, a binomial, or two terms, multiplied by another binomial. Let's go on to see how to do this. We start with the first term in the first bracket, and we multiply it by the first term in the second bracket. This gives ax. We then multiply the first term in the first bracket by the second term in the second bracket. This gives plus ay. We now do the same for the second term in the first bracket. In other words, we multiply it by the first term in the second bracket. This gives plus vx. And then we multiply it by the second term in the second bracket. This gives plus vy. We have now multiplied everything in the first bracket by everything in the second bracket, and we can't simplify further because there are no like terms. Some people like to use the word FOIL to remind them how to do this multiplication. F reminds us to multiply the first term by the first term. O reminds us to multiply the two outer terms. I reminds us to multiply the two inner terms. And L reminds us to multiply the two last terms. Please pause and try to memorize this pattern. Let's use FOIL to help us simplify this example. We begin by multiplying the first terms. X times x equals x squared. We then multiply the outer terms. X times plus 5 equals plus 5x. Then we multiply the inner terms. Plus 2 times x equals plus 2x. We end by multiplying the last two terms. Plus 2 times plus 5 equals plus 10. Are we finished? No, we have two like terms, so we can simplify further. 5x plus 2x equals 7x. Now we are finished. Please pause to check my working. Here is the next example. Let's again use FOIL to help us. We begin with the first terms. A times a equals a squared. Then the outer terms. A times minus 4 equals minus 4a. Then the inner terms. Plus 3 times a equals plus 3a. Then the last terms. Plus 3 times minus 4 equals minus 12. Are we finished? No, we again have like terms. Minus 4a plus 3a equals minus 1a, or just minus a. Please pause to check my working. Here is the next example. Please pause and try it on your own first. We begin with the first terms. 2x times x equals 2x squared. Then the outer terms. 2x times minus 3y equals minus 6xy. Then the inner terms. Minus y times x equals minus xy. And then the last terms. Minus y times minus 3y equals plus 3y squared. Are we finished? No, we again have like terms. Minus 6xy minus xy equals minus 7xy. Please pause to check my working. In the next example, we have two identical brackets with opposite signs. We again use FOIL. X times x equals x squared. Next, we multiply the outer terms. X times plus 5 equals plus 5x. And then the inner terms. Minus 5 times x equals minus 5x. And then the last terms. Minus 5 times plus 5 equals minus 25. Are we finished? No, we again have like terms. And this time the like terms cancel out, So the answer is x squared minus 25. In other words, the answer has only 2 terms. Please note, the answer will always have only 2 terms if the brackets are identical with opposite signs. Please pause to check my working. In the next example, we again have 2 identical brackets with opposite signs. Let's go on to see if we get an answer with only 2 terms. Using FOIL, we begin with the first terms. 2p times 2p equals 4p squared. Then the outer terms. 2p times plus 3 equals plus 6p. Then the inner terms. Minus 3 times 2p equals minus 6p. And then the last terms. Minus 3 times plus 3 equals minus 9. Are we finished? No, we have like terms. The like terms again cancel out, so we are left with only 2 terms in the answer, which is what we expected. Please pause to check my working. The next example looks different. Do you know what it means? The power of 2 tells us that we need to multiply the bracket by itself. In other words, we need to do the following, which is what we've been doing the whole lesson. We proceed as before. X times x equals x squared. We then multiply the outer terms. X times plus 3 equals plus 3x. And then the inner terms. Plus 3 times x again equals plus 3x. And then the last terms. Plus 3 times plus 3 equals plus 9. Are we finished? No, we have like terms. 3x plus 3x equals 6x. So the answer is x squared plus 6x plus 9. Please note, when squaring a bracket, there is a shortcut you can use. We square the first term in the bracket. We then multiply the first term by the second term and double the answer. And then we square the second term. This again gives the answer we got earlier. Please note, if you are comfortable with this shortcut, please use it. Otherwise, you are welcome to use the long method. Please pause if you need to. In the next example, we are again asked to square a binomial. If we use the long method, step 1 is to write the bracket twice. We then use FOIL. X times x equals x squared. We then multiply the outer terms. X times minus 4 equals minus 4x. Then the inner terms. Minus 4 times x equals minus 4x. And then the last terms. Minus 4 times minus 4 equals plus 16. We then need to add the like terms. Minus 4x equals minus 8x. So the answer is x squared minus 8x plus 16. Let's now use the shortcut to get the answer. We square the first term. We then double the product of the first and second terms. And we square the second or last term. This again gives the same answer. This completes the lesson. Good luck with the test.
Dear students, complete the homework from the exercises 9.1, 9.2, 9.3. Any 2 questions from each of the problem. And in the second video of today, you will have to learn more important informations on multiplication of polynomials. Okay, so watch that carefully. Meet you in the next class. Thank you.